So according to the graph, this graph shows the activities that cause a significant back pain. And from the graph, the activities that cause the most severe back pain include is the lift. As you can see, the strain on the back. It shows the most strain on the back comparing to carry or slide on curvature or pack 3 products. The lift show the most severe is the most cause of the back pain. So for the scope of study, the ISO 11228 minus 1 part 1, which is concerning lifting and carrying, will be used in our research. The theory does not involve movement of any lifting task. It just includes the way we lift and carry an object in a static time. And furthermore, the NIOSH lifting equation will be also further used in our theory. And this equation is the solution to evaluate the material handling list. And after solving this equation, the output includes we get the recommended weight limit and as well as the lifting index, which will be used to evaluate the list assessment by means that we will know whether we should lift this object in this manner or not. And the other scope of study includes we also want to make a mobile application. We want to put our theory that we have researched and make it into and input it into a smart mobile application. And the way to do this is developing a graphic user interface. And on the other hand, we want to make sure our mobile application is suitable for the Thai language type workers, which the unit will be in the Thai standard of living units of measurement. And also, aim to make the application suitable for Thai workers. And for the programming part, we will use the MIT App Inventor to program the mobile application. So in summary, all we will combine all these three theory, which is the NIOSH equation and the manual material handling ISO, and combine it with the mobile application to make sure that it becomes a mobile application concerning the manual material handling risk evaluation or assessment. So let me introduce the MIT App Inventor. It's a program that allows everyone to build an Android app for a smartphone. And this new MIT Inventor can have a simple first app running in less than 30 minutes, which means you can search on Google and launch it and create an application. So, and one of the first steps to make this mobile application is to make the mock-up model. This include inputting the theory, the ISO and the NIOSH equation into an Microsoft Excel and simulate to it the equation to understand the overall calculation. So this is the equation of the NIOSH equation. And here is the one of the theory that we put in the Microsoft Excel, the table that concerned with the lifting frequency. And also in the end, after we have covered up all the theory, we make sure we transfer the database into the mobile application. This is the programming part. We design the app in using the graphic user interface, which will include icons, menu by using touchscreen to go to the next page or to open the application. And this is first we design a paper graph unit test of the application by paper by hand to plan the pages of the mobile application. And once we have done that, we design the simple graphic user interface, and this is one of the our first type of mobile application, which includes all the equation first. And this is the sample of the programming part. Now we have transferred the database, the Nios equation, and put it in the program language in the MIT Inventor. And finally, it have been done. We successfully input all the data into the mobile application, and it's ready to be used as to calculate the manual lift. And then furthermore, it needs a menu. A mobile application needs a menu and a many screen just like a normal application. So we improve its user interface by using the Trunkable, which is based on the MIT App Inventor, as the Trunkable has more functions for controlling, for designing the UI.